So our speaker today is Dr. Doug Duncan. He is an astronomer at the University of Colorado, and he's the director of the Fiske Planetarium, which is self-proclaimed the most advanced planetarium in the US. He earned degrees at Caltech and the University of California, and he was part of the project that first detected sunspot cycles on other stars. He subsequently joined the staff at the Hubble Space Telescope, and in 1992, he accepted a joint appointment at the University of Chicago and the Adler Planetarium, beginning a trend of modernization of planetariums, which has spread to New York, Denver, Los Angeles, and now Boulder. So in his prolific career, Dr. Duncan has authored more than 50 papers. I hope I got that number right. And now he is heavily involved in education and public outreach. From 1997 to 2002, he did science commentary for Chicago Public Radio. And you now can hear him every now and again in Colorado Matters of the Colorado Public Radio. I actually heard him like only a few weeks ago. He has also appeared in various TV programs. And in 2011, he received a prestigious Richard Emmons Award presented to the outstanding university astronomy teacher in the US. So Dr. Duncan, correct me if you jump in.
All sounds good.
Okay.
I better listen to myself.
And I had to cut it down. So he's not only an educator, but he has delved into pedagogy as well. He's the author of Clickers in the Classroom, a guide to the powerful new technology that enables better teaching methods. He has also served as National Education Coordinator for the American Astronomical Society. And lastly, Dr. Duncan leads educational trips throughout the world to watch total eclipses of the sun and to see the northern lights. And today he's going to be talking about the upcoming Great American Eclipse of 2017 with the same title.
Good. Thank you very much. It's a pleasure and an honor to be invited to give this talk. I will try very hard to be both interesting and useful. And inspired by Tom Ayers, I will in good part describe the behavior of large mammals, people, and others during a total eclipse. I have some video of that as it turns out. So this is the plan for today's talk. And well, right now, to start off and to better target my remarks, I would like, please, a show of hands. How many people in this room have seen a total eclipse? Nope, just hands. And how many people have not? Fascinating. Okay, that's kind of what I was expecting, actually, that we're roughly 50-50. And it's interesting, even when it's your profession. It's not easy to see a total eclipse. It's also not easy to make observations and see a total eclipse. But at any rate, part of the presentation today will be the challenge of explaining to people who haven't observed, and then for everybody, what will you be doing on August 21st. Some of you, I hope, by the end of this talk will be volunteering, if you're not already assigned on that day, for reasons I'll explain. Okay, but it's kind of fun to start with just a little bit of history of eclipses. It turns out we have an excellent author, very interesting man who lives in Boulder named David Barron. If you've been around Boulder for a while, there was a very popular book 15 years ago called The Beast in the Garden. He was the author of that, and 3 or 4 years ago, he got very interested in eclipses and started researching them and wrote a very interesting book about the last great American eclipse, which was in 1878. In the preface, he says something that's important to 50% of you. He said, I'm a science journalist, I know a lot about science, I thought I knew what to expect during a total eclipse. If you haven't seen one yourself, the answer is you may think you know what to expect, but you don't. And I'll do my best to describe that. David Barron is coming to town, or I guess he lives in town, but he's coming to give a public talk May 7th at Fiske Planetarium. This eclipse was especially interesting for a number of reasons. Young Thomas Edison got interested in the eclipse, and he had just, I was thinking of this with this morning's papers on the IR spectra of the sun. I'll bet you may not know that the first infrared detector was invented by Thomas Edison and brought to Colorado and Wyoming to observe the sun's corona. Edison made his own expedition of himself and his own press agent. Apparently, by the age of 27, he already had his own press coverage wherever he went. But he had never used a telescope. And so he had quite some problems with the actual field conditions in Colorado and Wyoming. In particular, we have something called wind. And he tried to put his little instrument on the end of a refractor, and it kept blowing and blowing, and it wasn't working out very well, so he moved it to a chicken coop, which was great because it was open to the sky and it had big walls that would block the wind. Unfortunately, during totality, when it gets dark, guess what chickens do? Cows go to the barn, chickens go to the chicken coop. That didn't help his observations. It took him 2/3 of the 3-minute eclipse to finally get the sun's corona through the slit of his infrared instrument. And when he finally got the corona to go in, the needle immediately went all the way and pinned at the top of the range because he hadn't thought to calibrate it. And so he couldn't take a quantitative measurement, but he knew there was infrared coming from the corona. So that's part of the story that David Barron would tell. There was a very famous at the time, not so famous nowadays, astronomer, head of the department at the University of Michigan, who led a big expedition to Denver and to see the eclipse. He was famous for discovering 22 minor planets, and he discovered a planet Vulcan during this eclipse, which has, of course, not subsequently been verified. And then finally, Maria Mitchell, probably America's first very famous woman astronomer, she wrote to a number of the expeditions and said she'd like to come along and observe the eclipse, and she was rejected by all of them for being female. So she formed an all-female astronomical team, and they came out to Denver. I believe they rented a house in downtown Denver, and they did their own observations. A lot of people went up Pikes Peak for that eclipse. So it's an interesting story. So if you like historical eclipses, I encourage you to come May 7th to Fiske Planetarium and hear the author. That's the day the book will be released. One other historical eclipse, I only plan to talk about 1878, but I just happened to encounter recently a very famous French photographer, Auger, and just so happens that this is an eclipse also. Some of you will recognize where it is in downtown Paris, 1911. Well, I wanted to give you just a couple of minutes of my own background and why I'm so pleased to be part of this meeting. As a student at Caltech, I was randomly assigned an advisor named Hal Zirin. And the next thing I knew, I spent my summer working at the Big Bear Solar Observatory, taking lots of H-alpha and calcium K images on film in those days, of course. And although when I left Pasadena, I swore on the way out I would never return, some years later, in 1980, I came back as a postdoc and worked 3 years as a postdoc and 2 or 3 years as a research scientist at Mount Wilson Observatory, doing observations, collecting data that I know that a lot of you have used. It's kind of fun to look back at one of my pictures of the whole crew, Olin Wilson in the center and Art Vaughn, who built the instrumentation that I later maintained. Some of the observers, Kay Swan, Bob Noyes. And as you heard, we did lots of observations over many years of cycles, and because we were pretty careful about our data analysis, and I always teach this lesson to my students. I'm teaching right now the undergraduate data analysis class over on campus, that the scatter from observation to observation, month to month, was bigger than we thought our measurement error was. And that's because the scatter is caused by a real signal. And when a number of astronomers all pooled telescope time so that we could observe continuously and not just for a few days each month, we found indeed there's a fascinating signal, and that signal is the rotation. And so a whole new industry came out of being careful with the data analysis, I tell my students. Well, it's been quite a while since there was a total eclipse of the sun in the continental US. And as a matter of fact, it was long enough ago that the last eclipse was narrated by someone quite famous named Walter Cronkite.
This is the CBS Evening News with Walter Cronkite.
Good evening. For parts of North America, the sun went out today. For a little under 3 minutes, the forces of darkness ruled in daylight as a great swath of shadow up to 190 miles wide cut across the continent from the coast of Oregon to Greenland. It was the last total eclipse of the sun for North America until the year 2017.
And everyone thought that 2017 was almost infinitely far in the future, right? But here we are. Okay, so this is a modification of the map that you saw before. It was done by one of the students who's an artist at Fiske Planetarium on campus. And I really like it because I think it gives, especially the non-specialist, an intuitive idea of how complete this eclipse is going to be. So that's what it's going to look like in New Mexico and Arizona, all the way up into Canada. And of course, that is the band of totality. Now, although this is a good map, it's easy to be fooled by it. And in fact, I would like to convince everyone here to think about this eclipse in a slightly different way. And if you're part of the 50% in here who have not seen a total eclipse, almost everybody in that circumstance doesn't really visualize what's going on. And the reason is probably maps like I'm offering to people, okay? So the most important thing I'm going to say to half of you today is do not think of something like the situation in Denver as a 95% eclipse. Even though it is, don't think of it that way. Think of it as a 5% of the sun is visible eclipse. Because the thing that really controls what you see without any instrumentation is in fact the sun. And the reason for that is that the sun is roughly, I did the math, 400,000 times brighter than the full moon. So 5% of the sun, you're way ahead of me, is 20,000 times brighter than the full moon. And if even a few percent of the sun are still visible, it stays light. And all of the interesting phenomenon you can observe during a total eclipse are not visible. Okay? So, especially for non-specialist friends, I hope by the end of this 45 minutes or so, you're going to be really excited to tell them, get up to Wyoming and don't settle for seeing a 95% eclipse if you can manage to do that. Now, it's been since 1979 that we have had a total eclipse in crossing the continental US. A lot of people are surprised to know how many total or annular eclipses there are if you're willing to travel. So very roughly, every 2 or 3 years, there's a good total eclipse somewhere on the Earth. It just means you have to travel a lot. I discovered this when I was a freshman at Caltech in 1970, and there was a relatively close eclipse, only 5 days' drive from Pasadena. It was in Oaxaca, Mexico, and I will always be thankful to the dean, who I wrote a little note to, who came back and said, of course it would be a great idea to skip 2 weeks of school. Go, see and photograph the eclipse. So 2 friends and I, my size actually, piled into a VW Bug, had water and food for 2 weeks, telescopes, cameras. I'd be 2 inches taller if it hadn't been for those 2 weeks. But we drove to a tiny village outside of Oaxaca, Mexico, right on the central line. I think we were the first tourists in history in that village. We introduced them to a concept called Frisbee, which none of them had ever seen. And we saw 3 minutes and 20 seconds of a marvelous total eclipse. And it was such an experience, you know, a scientific experience but a very emotional experience too, because as I say to people, a total eclipse looks a lot like the end of the world. And if the end of the world was to somehow appear outside, you don't say things like, wow. You say much more, use much stronger language, which I will prove to you in a few minutes with a tape from an eclipse. So I kind of got the bug, and I have chased eclipses all over the world, and I discovered early on that a lot of people love astronomy, and if you're willing to take the time to explain it to them in language that they understand and find engaging, they will actually pay you to take them all over the place and see an eclipse, experience it. And so I've done that many different places with a lot of memorable results. This crew was from an eclipse in the Galapagos roughly 15 years ago, and that was fascinating because we watched it in the company of dozens of whales and dolphins who all surfaced 5 minutes before totality, watched the total eclipse, and 5 minutes later swam away. So as I will detail to you a little later in this talk, not only should you be watching the eclipse, but you should be watching for the reactions of any animals in the vicinity where you see it. The biggest excursion expedition I ever organized was for an eclipse in 2006 in the Greek islands and Egypt, and I took 402 people to that eclipse. I had to hire 11 astronomers and Davis Sobel to give talks on that, and we all had a very fascinating time. The last eclipse that I led people to was in 2012 in China. A lot of people went to that. A lot of people didn't see that because the whole coast was raining, you know, all the way from Nanjing down to Shanghai, and the totality passed through Suzhou. But looking at the satellite maps on my laptop, I could see that every day it rained on the coast 400 or 500 miles inland toward Wuhan. It was clear. So the night before the eclipse, we all boarded buses at midnight, and we drove for 8 hours. And just as the eclipse was starting, we broke into the clear and watched it from the parking lot of a concrete block factory in some random Chinese city. So should you make it your personal plan to see the total eclipse, and if you're not working and if you have the ability to go where you want, an extremely valuable book, I'll show you a slide of it, is called the Road Atlas for the 2017 Total Eclipse. It's just a nice, normal road atlas with all of the eclipse track in great detail overlaid. So should you have to change where you think you're going, you can remain within totality as you know you drive for hours and hours to get away from clouds. I have to finish up my own personal history with eclipses to tell you about the best one that I missed. And that was that I figured out several decades ago that the speed of the moon's shadow, which crosses the Earth in roughly 2 or 3 seconds a mile, is almost identical to the speed of the supersonic Concorde. So, and I know that in the early 70s there was actually a scientific use of the Concorde. But I just contacted Air France, found a man who had chartered the Concorde and suggested to them they let us charter it so that 100 people could see a lifetime's worth of eclipses out the window. And that's what it would have been. The entire flight, once we rendezvoused with the shadow, would have been total eclipse out the windows of half the plane, not the other half, right? Turns out the Air France loved the idea. They flew me first class to Paris. They flew my partner who was putting up the money on the Concorde from Manhattan to there. And their chief pilot turns out to be an avid amateur astronomer. So we had all these wonderful plans, came back to Chicago, and 1 week later, before the contract arrived, somebody came in my office and said, don't you love the Concorde? Did you hear it just crashed? And that was the plane we were going to charter for the eclipse. So we didn't do that. But you have to try, right? Okay, so especially for the people in the audience who have not seen a total eclipse, and even for those who have, if you're fortunate enough not to be operating apparatus, I'd like to give you a few suggestions of what you might do and some of the interesting things you might observe. So the first thing I have to admit is try as hard as I can, I'm going to fail. And here's why. Okay? Suppose I was trying to describe the Grand Canyon to you. How many people here have seen the Grand Canyon? How many have not? Okay. Well, this is not the Grand Canyon. This is a beautiful photograph of the Grand Canyon. But I would imagine most people in the room would agree with me, since almost everyone raised their hands, when you actually see the Grand Canyon, it is so much larger and more magnificent than any photograph can show that most people, when they first walk into the canyon, are just speechless. And I would claim that the Grand Canyon itself bears the same relationship to this picture of it as the experience of a total eclipse bears to the pictures of the total eclipse. Don't forget that with that enormous range in brightness from daylight sunlight to nighttime stars, your eye handles all that dynamic range. And photography certainly comes nowhere near. And so the dynamic range that you see, particularly in the corona and all the detail with just your eyes, or with your eyes and binoculars, far surpasses any photograph. I mean, HAO did the best job I've ever seen with radial gradient filters and doing photography, but it still doesn't match the dynamic range of your eye. So for those about to experience the eclipse, if you happen to be on the 70-mile wide path of totality, it takes, well, there's a lot of suspense with nothing happening, because any sensible person who wants to observe an eclipse gets to your observing site way, way early, right? And that's particular danger, I would say, here, because totality is right up I-25 in Wyoming. You know that, but so does, by the time the eclipse comes, so will every person in Denver. And it would not surprise me if 100,000 people tried to drive up I-25 the morning of the eclipse. So please don't do that. You will probably be caught short of where you want to be, and maybe in a 40-mile-long traffic jam. My first eclipse in Oaxaca, Mexico, they brought out the National Guard to direct traffic. There were so many people trying to crowd into where totality was. And I know for a fact that there have already been a number of meetings of the Highway Patrol in most of the states along totality. So go early, you know, establish your viewing location. And then you wait and wait and wait, and finally the partial eclipse starts. And it's always seemed to me that it takes a long time, even though it's only about an hour and 15 or 20 minutes, for the partial eclipse to turn into a total eclipse if you're in the region of totality. So an hour and 15 minutes of slow, 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 and because our eyes have a logarithmic response to handle the dynamic range. You know, if you ask somebody to turn up a rheostat on a bunch of light bulbs and say, make the brightness 1, 2, 3, 4, 5, and they do that by eye, and you measure the energy output, the ratio is actually 2, 4, 6, 8, and so on. Okay? So all through the partial phases until almost here, there really is little or no observable change in the landscape. But then, you know, once you go, so when you go from 90% obscuration to 92%, no real big deal. But when you finally get 98% covered, then 99 and 100%, then it seems to accelerate. So you watch the partial phases for a long time. I think everybody has seen that you can make a pinhole camera. It's always explained like this. It's a little more fun if you take, say, a hotel key. You can make a bunch of little pinhole cameras. You can take a woven blanket. We did this, well, a friend of mine did this in 2012, and she held up her blanket, and she had 1,000 little pinhole cameras from the blanket that she wove. And then, even if you don't have anything trees, make wonderful pinhole cameras as light filters through the leaves. So that's always something to look at an eclipse if you're in a place that has trees. Now, I mentioned the shadow crosses the Earth 2 or 3 seconds per mile. Depending on where you are, if there are mountains in the distance, and this is in Jackson, Wyoming, in Grand Teton National Park, those mountains are 10 or 15 miles away, right? And so that means totality will reach them 30, 40, 50 seconds before us. So what actually happens, and I've seen this several times, and it's very eerie, is one by one by one, the mountains disappear. So everybody starts to get really excited as totality gets closer, people's voices raise in pitch, even professional astronomers. And then one of the first things that signifies totality is somebody spots Venus. You can usually spot Venus a couple of minutes before totality. And then finally somebody says, the mountains are going, the mountains are going. And one by one, they disappear. And then you get enveloped in totality. Just at that cusp, at a few of the eclipses that I've been to, not most of them, we've been able to see shadow bands rippling across the landscape. And then you're in totality, and it's wonderful. And an English astronomer by the name of Bailey was absolutely mesmerized by the fact that you often see beautiful little glowing areas that are now called Bailey's beads in his name, often where there are valleys along the edge of the moon. You've got mountains sticking up, valleys letting a little more light through, and you get the beautiful Bailey's beads phenomenon. I would say that probably my favorite personal thing to observe during a total eclipse are the prominences. I mean, we've all seen the beautiful satellite images. You can vary the wavelength of your observation from H-alpha to UV to X-ray. You can see the chromosphere with our instruments. You can see the corona with our instruments. But somehow to just see with your eyes a beautiful, very striking prominence like this, as I'll describe when I give a few suggestions in detail, I always have a nice pair of binoculars at a total eclipse. And I would say that looking at the prominences and the detail in the corona with your own eyes with a magnification like that is one of the most beautiful things I've ever seen, and fascinating. I brought my mother when she was 70 to a total eclipse. And at the end of the 3 minutes, she just had tears running down her cheeks. She said, I've never seen anything with such a beauty in my life. So the prominences are there to look for, and binoculars really help. And then the incredible detail in the corona. So yeah, a lot of things to look for in 2 minutes and 20 seconds, right? So how do you do that? I have some very practical tips right now. So here's a short list of tips. At my very first eclipse, I was very fortunate. I thought, you know, I don't really want to be looking at my watch rather than the eclipse. So what if I just tape recorded a countdown? That eclipse in Oaxaca was 3 minutes and 20 seconds. So I tape recorded 3 minutes 10, 3 minutes, 2 minutes 50, and I had a nice little tape, and I pressed play when totality started. And my plan, honestly, was to take maybe half a dozen pictures with the telescope and camera I had brought, and then watch most of the eclipse. The first time I became aware of my tape recorder, it was saying 50 seconds left. So I'd already gone through 2/3 of the eclipse, and I thought it was just a brief instant of time. I thought I'd taken 6 pictures. Turns out I took 25. But I still was able to see the eclipse because it reminded me. So save the seconds it would take to look at your watch. It's too dark to see it easily anyway, and make some kind of a recording. Start it with totality. Use a pair of binoculars like I suggested. In addition to what I'm sure you would be primed to see, the chromosphere, the prominences, the corona, notice that you are at the center of a circular sunrise. The shadow of the moon at this eclipse is 35 miles roughly in radius. So if you're in a place where there's a flat horizon, you can, and it's not smog, you can usually see 35 miles. And so instead of sunrise being east or west. Let's see, sunrise over in the east. It's all around you because it's still light out there. So that's kind of cool to see. And like I said, Venus is usually appears a couple of minutes before. Okay, so I claimed that large mammals and even not so large mammals behave strangely at eclipses, and I have a video to prove that. It's a very fun video. It's actually the most popular thing I ever do when I teach intro astronomy over on campus, because I tell people I have a video at an eclipse where I was surrounded by college students. And even though the video is now 20 years old and the quality isn't great, and it wouldn't matter because our videos don't do justice to the dynamic range of the eclipse, we can capture audio pretty well. And so now I have to give you the warning that I always give my students, which is the following short video is R-rated for language. If anyone is potentially offended by R-rated language, now would be a good time to leave the room, and you can come back in about 6 minutes. I always tell them, you know, the class before, we're studying eclipses. I have a video of the eclipse. It's R-rated for this reason. So if you want to come 10 minutes late to class, next class, you can do that. I have perfect attendance. Okay. Sometimes they bring their friends. So if something looked like the end of the world, which to a large extent it does, college students don't say, wow. They say a lot more colorful things. So let's take a look at a little bit of this video. It was the longest total eclipse of my life, 1991. It was in Hawaii, and ironically, all of the great observatories at Mauna Kea were clouded out and got no observation. Some of you may have been there, but in Cabo San Lucas, it was totally clear, and that's where this was taken. So let's have a little bit of fun with this video. Oh, we were on a ship? So it took about 20 seconds on the moving ship to get the telephoto lens and camera onto the sun. So be patient. Totality just started. But we're centering the image. Here it comes.
Oh my God! Holy shit! Oh my God, that's beautiful! Straight up now. No, you don't need this. You don't need it. Just look straight up. You see it? Oh, you won't believe the view in here. Oh my fucking God. You will not believe how beautiful this is.
So the sensitivity of the video camera is being turned up and down to capture inner corona and as much of the outer corona as we could. You know, that's about 10% of what you could see. One of my favorite parts of this eclipse, let's see if I can move us here. There's just a wonderful prominence right about here. And during the 6 minutes, you could easily see changes visibly. It was wonderful.
Well, you can see the end of it coming.
Change the exposure a little bit, and that'll let us see it better, I hope.
No.
Jay, enough pictures.
This looks like one of those early wood cuttings.
If you got my one. Did you get my one?
I got as much as I could. Look at the crisscrossing around the
Here we go. This will be better. Yeah, look at that.
The streamer. That must be near the pole. Wow.
Joey, polarizer, that thing looks pink.
Yeah.
What does? The prominence on the upper side. Let me look.
It's so bright. You can see it.
Yes, it's just like a full moon.
It doesn't look real. Look at it. Oh, it sure does. Yeah, it looks reddish. The thing's enormous. I know, that's the back edge.
See the pink color?
Let's see.
I want to rotate the polarizer so I get any other color.
So this is when you should be looking with a pair of binoculars. And you should be ready to put them down.
It's a major solar prominence.
My God, that prominence is unbelievable. The streamers,
I'm trying.
they're really long.
Every totality ends with a beautiful diamond ring as a little bit of sun comes back, and you're about to see that. It's very, very obvious.
Yeah, take the
Totality. Your safe viewing filter as soon as you see that diamond ring effect.
It's coming out of the prominent side. There it comes, diamond ring. Oh yeah. It's getting.
So aren't we fortunate to live on the only planet in the solar system with almost a perfect coincidence in apparent size of a moon and the sun? Well, I promised you that animals do strange things, and that includes people. So here is a very short recording combining the animal behavior at two different eclipses.
One of the most amazing things about any total eclipse is that the animals always freak out the same way the people do. People scream and shout and applaud when the total eclipse happens, and the animals do strange things. At one eclipse, we were in Bolivia, and we're all looking at the total eclipse when somebody shouts, "Look down, look down!" And we do, and we're surrounded by llamas. I don't know where they came from. When the eclipse was over, they all lined up in a line, and they marched away. At another total eclipse in the Galapagos, we were on a small boat, and 5 minutes before totality, every whale and dolphin in the vicinity, dozens, surfaced and swam back and forth and watched the eclipse with us. 5 minutes after totality, they all swam away, and we never saw them again.
Okay, so I mentioned to you this very valuable book, useful for last-minute changes in observing plans. Another very practical source of information is Jay Anderson, who is a Canadian meteorologist who has made eclipse weather his hobby for the last 30 years or so. So you can Google Jay Anderson and go to his website and learn about the weather prospects for the eclipse. I'm very pleased to say the following, and that is that working with 3 other astronomers, come back, I have been able to secure funding for 2 million safe eclipse watching glasses to be distributed all over the U.S. The primary funding is from the Gordon and Betty Moore Foundation. Thank you very much to them. An astronomer some of us know, Bob Kirshner, is part of the Gordon and Betty Moore Foundation nowadays, and he backed this project. Google came in at the end with a little bit more money, and so we're furnishing educational material and 1,000 safe eclipse watching glasses to each of 2,000 libraries all over the U.S. Those libraries have their own website, and they are looking for help. To help a library prepare to serve their clientele for the eclipse does not necessarily mean that it has to interfere with your plans, because almost all the planning that the libraries are doing is in the months leading up to the eclipse. So if you happen to be willing to be a volunteer expert who can answer some questions of the librarians, they would love to have you, and all you have to do is go to this website. It's called star_net. and you can look to see if there's a library that you'd like to help out. Actually, if the library where you live, if I haven't even had a chance to check with the local area libraries. I don't know if somebody is helping out Longmont and Lyons and so forth and so on. But if you're willing to, just go to the website and tell them your name, and you can match with a library because the librarians have a lot of questions. If you're really in the help somebody out mode, you could adopt a school. One of the manufacturers of the Eclipse glasses has decided to give discounts to people who are educators. And so if you go to the website eclipsediscount.com, they have various sized boxes of Eclipse glasses designed for educators to use. Oh, and of course, because we're in Boulder, McGuckin Hardware and the Fiske Planetarium have about 30,000 safe eclipse watching glasses in stock, and so you can get some at those two locations. It's kind of fun. Back in 2012, there was a transit of Venus and about a 3/4 eclipse here, and I talked McGuckin Hardware into stocking eclipse glasses. And after the partial eclipse, I interviewed one of the several of the McGuckin people, and it's pretty funny what they say about eclipses now. I'll treat you to about 30 seconds of what they say. Oh, I got to get it to go.
This
where I
eclipse
want.
can be seen from every state in the continental U.S.
Here we go. To about here. McGuckin was pretty happy with the eclipse.
First, it was very easy. You know, we do our normal procedures. We'll put them on hold for customers. But the volume quickly increased. We had to just tell people that it was first come, first serve. We're limiting 2 per customer because they're going to evaporate. And they did, over and over again.
Sometimes customers would be mad at us. It's like, well, what do you mean you ran out? Why didn't you order more? It's like, well, I thought 2,000 was enough. We never ordered 2,000 of anything, and we sold out. And we ordered 2,000 more, and we sold out. And we ordered 2,000 more.
We had a line in the store from the reception desk, probably going almost to the middle of the store, of about maybe 100 to 150 people, waiting and hoping that they would get some eclipse glasses, the final ones.
It's a you gotta have it thing. It's like Beatles tickets. It's like sandbags in the flood. It's like almost panic mode. Oh, I gotta have them, I gotta have them. Finally, right up until the eclipse, and finally sold everything we had. In my 37 years, I can't think of any one product that created this much excitement. It was like, well, where are you gonna watch it? You going to a party? You going to the stadium? Yeah.
Okay, I guess that's enough of McGuckin. If you decide to help a group of people watch the eclipse, my experience is the best way to watch the partial eclipse is to project an image of the sun.
If you have access to a pair of binoculars, you can make an excellent image of the sun. Don't look at the sun, of course, but let the sunlight go through the binoculars and out the eyepieces. Take a piece of white paper, focus the binoculars until the edge of the sun's image is as sharp as can be, and then look, you can see a sunspot and another sunspot. And this is a great way to see an eclipse, a great way to see Venus in transit passing across the sun. This is a lot easier if you can put your binoculars on a tripod like I've done here. A lot of camera stores will sell a little adapter. If you can't put them on a tripod, put them on a table, prop them up with some books.
So you get the idea. In 2012, we set a record by putting 10,000 people into Folsom Stadium, and I'm pleased to tell you that I've gotten 9 News Denver very, very interested in this eclipse. And in fact, NBC National is pretty interested in it. And so even though you can't publish this yet, NBC Denver is trying to rent the Rockies Stadium in Denver, Folsom Field in Boulder, and the new Fort Collins Stadium. And I happen to know that CU has already said, yeah, you can use Folsom Stadium. So for the poor people who are at work on that Monday and can't go to Wyoming, that's a pretty good thing to do. I was going to make a couple of quick remarks about science during the eclipse, but that really is other people's place better than mine. So I'm just going to move to the end, which is 3 useful websites. We somehow talked the University of Colorado into giving us a nice, easy-to-remember website, which is the main university just /Eclipse. And that brings you to the Fiske Planetarium's website of information about the upcoming eclipse. I've been fortunate enough to do, if you know about Coursera, that is a website that offers hundreds and hundreds of college classes from leading universities, all different topics, and you can take them for free. If you want to take the quizzes and get a certificate to prove that you've completed, you have to pay a little bit, but otherwise the course is for free. And I have a 5-hour, 5-meeting course, I should have said. Bunch of short videos and questions and so forth about the sun, how astronomers observe the sun and stars, how spectroscopy works, and then the last of the 5 meetings is all about the upcoming total eclipse. And then the last one I already mentioned. So I promised to make up a little bit of time, so I think I'll stop here, and I hope there's a bunch of questions. Thanks a lot. I see one already.
Thank you. All right. Questions for Doug? Annie?
Yeah, my question is the Trot Atlas.
Yes.
List major zoos.
Repeat the question about the atlas.
I'm asking whether it lists major zoos in the area.
Zoos?
Well, you mentioned the
Oh, for the animals. No, there is no symbol for zoos. There's very nice indication of how long totality will be in various places. I think you have to find the zoos on your own. I myself will be leading about 300 people to Grand Teton National Park. You should have seen their faces when I reserved rooms for 300 4 years ago. You know, they said, when? And then they looked on their reservation system, and believe it or not, the week before was reserved 4 years ago, and some of you probably know why. The Federal Reserve has a meeting at Jackson Hole, right, every summer in August to, release information on the economy, and they had booked the Jackson Lake Lodge the week before us. Fortunately, they don't know that there was an eclipse. Anyway, that is a national elk reserve, and it has hundreds and hundreds of elk, moose, and buffalo. And there are herds of them everywhere. So I think in that location, I'm definitely going to bring an extra video camera and just put it on the horizon and see what happens, right? There was a question over here.
This is less a question, just to let you know that the National Solar Observatory has its own Eclipse website as well.
Oh, good.
It's eclipse2017.nso.edu. 2017 is, of course, numerical.
Alicia.
So what's the deal with school starting before the eclipse? Have you guys done anything about that?
Well, I'm glad you asked that. I have a piece of good news and a piece of other news. The piece of good news is that 3 years ago, I looked at the CU calendar and I said, gee, we always start on either the 3rd or the 4th Monday in August. And it varies from year to year. I wonder what it will be in 2017. So I fired off an email to President Benson's office, actually, and I got it answered within 24 hours. Honestly, I'm not making this up. The first email back to me said, would you consider changing the time and date of the eclipse? Only time in my life I ever saw Bill Camphor tell a joke. 5 minutes later, it came and said, we will be sure and open CU on the 28th in the year 2017. So CU actively decided to not open on Eclipse Day. I wish I could say, that's the good news. The other news is BVSD was not in on this. And the worst news of all to my amazement, is that the University of Nebraska, which most of you know has an enormous football stadium, which is within Totality, they're opening on Eclipse Day. So I don't know what's going to happen in Lincoln, Nebraska, but I'm not going to worry about that. It just seems sad. Oh, hi, Claire.
The STEM coordinator for BVSD has said that Eclipse Day will be an acceptable day for your kids not to go to school. Now, I don't have children in school here, so I don't know what that means, but they know that it's coming, and they, I believe, are going to be very flexible. So I think you can take your kids out of school that day, but they won't be promoting you taking your kids out of school that day. So I think it's a delicate thing.
Yeah. Oh, there's one.
So I do have kids in the BVSD schools, and that's why I have a comment, and I think it's a good thing that the schools are open, because, you know, my kids are going to go somewhere to see the eclipse. That we know for sure. But a lot of other people cannot afford to go and see the eclipse, and I think that it will be good for a lot of us, you know, to promote the event at the school level and make sure that the science teacher, whomever teacher is there, you know, takes them outside and let them see the eclipse during the day. And there is all this initiative to provide the glasses to all the kids in the Boulder Valley School District so that they can do it. You know, staying home when you cannot travel and maybe your parents are at work, maybe it didn't work out so well. So.
And just to second that, like I said before, you know, maybe working with Claire or working with me, if some people in the room want to hook up with some schools, to hook up with the libraries, that's already been organized, and you just go to the website and you can click. Every library so far that's signed up has a little flag. Maybe you could just contact a library and make sure that they're in on this too. So helping the schools and libraries is great. Yes?
I see that you're doing amazing things about this upcoming eclipse. Every eclipse I've been to, there's a huge amount of news media about the deadly, blinding eclipse light and the great perils of looking at totality. And so many people hide, actually, even on path of totality.
I'm so glad that you asked that. Let me see if I can trigger this. Wait a minute. Well, I'll tell you what. If you go to the main Fiske Planetarium website, we have a 4-minute public service announcement which tells what's coming and how to watch the eclipse. But we have another 4-minute video, frequently asked questions. And the very first one is the one you described. It's one I've seen at every eclipse. It's, isn't there dangerous radiation on the day of the eclipse? And we answered it the way I've always wanted to answer it. We have pretty crummy actors, myself and 2 CU students. And the 2 CU students run up to me and say, oh, isn't there dangerous radiation on the day of the eclipse? And I say to them, yes, it's called sun. Okay, the sun radiates every day, and you would never look at the sun, and the point is it's the same on eclipse day. So I have found that to be the most effective response, because you just kind of bring people back to common sense. It's the sun. You wouldn't look at the sun today. And when half the sun is covered, as we said, it's so powerful that you still can't look at it, and so you need to protect your eyes. The second most frequent question is, oh, I have sunglasses. I'll wear them to protect my eyes. And that's the second of the frequently asked questions, which point out that you need something 1,000 to 10,000 times darker than sunglasses, and the glasses people have on in the picture are not sunglasses. So the frequently asked questions video is really useful, and I hope that will spread around. I agree with you totally. That's the question we get every time. And of course, we won't reach everyone, but we're up in the millions, so we're getting there.
Well, thank you. It's so sad when people don't.
It is sad, especially sad when students get kept inside, so they can't see it. But we know that, you know, the American Astronomical Society, NSO, a lot of groups have been doing what they can and we'll see how far we get. It couldn't be worse than 1979, when as a grad student I was up at Totality on the Oregon-Washington border, just off of a road, and right in the middle of Totality, a semi came rolling down the road, and when the total eclipse happened, he flicked on his lights, and he kept driving. For real, for real. It never stopped. Guess he wasn't curious about what was going on.
Yeah, do you have any pointers or suggestions for photography and videography?
You know, that's so frustrating. If you could hear that in the back, it's such a dynamic range challenge to get either still photographs or video that is close to what you see. And it's virtually impossible to do both, to do photography and see the eclipse. Now, nowadays, fairly inexpensively, a couple $100, you can get gear which will control a digital single lens reflex. So if I was going to do photography, I would program in an enormous amount of bracketing, many, many f-stops. I would totally automate it. I'd stick it on a little clock drive mount, and I'd turn it on, and I'd not pay attention to it during totality.
When it wasn't actually cloudy on Mauna Kea for the 91 eclipse, and various groups used the telescopes. One, Serge Couchemy, used the Canada-France-Hawaii telescope to observe the corona, and that was actually the first 4-meter solar telescope. Which
wow.
Only
So, you know, I had friends, maybe they were at Halepohaku at 9,000 feet, and they saw nothing.
Lower down.
Wow, okay. Fascinating. Yeah, I didn't realize that. Yeah. Wow.
Oh, one more?
Hey, Sherry.
So I'm curious, you can't look when there's any part of the sun exposed, but how do you counsel people about the diamond ring effect with the naked eye? What do you say to them? Is it okay to witness that and then, protect?
Yes. You know, the brightness comes back so rapidly at the diamond ring that I've always just told people the end of totality, the sun will start to appear. It'll get brighter very, very fast in a matter of a second or two. It looks like a little diamond, and then you turn away.
Right, so you can...
Yeah, you can look at the diamond
say?
ring for several seconds.
Cool.
At least I've done it 10 times so far.
And
so
you're
far, so
you're still seeing.
Yeah.
Okay, good. Thank you.
All right, well, thank you again. Let's thank Doug once again for his wonderful talk on the eclipse. And that concludes 2017 Boulder Solar Day. I'd just like to end by thanking Northwest Research Associates, Southwest Research Institute, HAO, NCAR, NSO, and LASP as this year's sponsors. And we'll see you next year. Thank you.